Hello students, welcome to the class of chemistry. Myself Dr. Shilpi Gupta. In my last video I started the topic of phenol. Okay, so in my last video I explained you the acidity of phenol and resonance. Acidity of phenol due to resonance. So let's have a quick revision of it, then we will continue this topic further. Okay, so what is acidity of phenol? I explained you that when phenol dissociates in aqueous solution, it forms phenoxide ion, means it loses a proton, and acidity is giving proton. This phenoxide ion is stable. Its negative charge spread throughout the ring, which means it has delocalization of charge, which means it has resonance. And due to the delocalization of charge, this phenoxide ion is stable. This negative charge moves throughout the ring, and that's why it is a stable structure. Okay. Now, how this negative charge spread throughout the ring is, this is the phenoxide ion. Okay, when this negative charge comes here, then this bond is pair of electrons. It comes at the carbon point to satisfy valency. Okay, now a structure forms like this. Now here double bond O comes. This is the carbon point which has lone pair of electrons. Okay, now when this lone pair of electrons come here, then this bond come at this carbon point. Means this pair of electron comes at this carbon point to again satisfy the valency. Now this is negative charge is spreading throughout the ring. Okay. Now here double bond O, and this negative charge is here. Now in my next step, this negative charge will come here. Then this bond will shift at this carbon point, and a structure will form like this. Now when this negative charge comes here, one of the double bonds shift at the oxygen, and the structure will form like this. So this is a stable phenoxide ion, which means resonance. Now in case of alcohol, why phenol is more acidic than alcohol? In case of alcohol, there is no chance of resonance or delocalization of charge. That's why the oxygen atom firmly attach the hydrogen and do not allow the acidity. Okay, do not allow the acidity. But here, due to the spread of the negative charge, it is acidic, and that's why it gives the proton. Okay, now there are some factors which affects the acidity of phenol. Okay, what are those factors? There are some electron attracting group which attracts electron towards itself. And number two is there are some electron repelling group. This is an important question for your exam. Factors affecting the acidity of phenol. Electron repelling group. So electron attracting groups are those groups which attracts electron towards itself, and electron repelling which do not attract the electron, which repels the electron. So first we will do electron attracting group. Some electron attracting groups are, as you all must know, nitro group, chloro group, cyano group, aldehyde group, acid group. These all are electron attracting group. So how these factors, how these structures, these atoms affects the acidity of phenol. Okay. So when these atoms, like suppose nitro group, let's take an example of nitro group. When this nitro group, first of all, phenol dissociate into phenoxide ion. Okay. Like this. But if there is a nitro group attached to the benzene ring at the suppose para position, then how it will affect the acidity of this phenoxide ion will be affected. How it will affect the acidity of phenol? Okay, this is this is para nitrophenol. How it will affect the acidity? Okay, so we will do this. the structure of nitro group is like this. You write it like this. Here is a negative charge, here is a negative charge, and here is a positive charge. So what happens? This is the phenoxide ion. Okay. First, this para-nitrophenol dissociates in presence of acid into the para-nitrophenoxide ion. Now, how this will affect the acidity? Okay, how this group will affect the acidity? This is an electron attracting group. How it will affect the acidity? So, what will happen? Again, due to resonance, the phenoxide ion will perform the negative charge delocalization. Okay, so this negative charge will come here, and then this bond will come at this point. Okay, so what will happen? When this negative charge will come here, it will get double bond O, and here will come like this. Lone pair of electron will come at this carbon point. Okay, it's like this. This has positive charge. Okay, now what will happen? This lone pair of electron will come here. So this bond will come at this carbon point where nitrogen is attached. So what will happen? This bond will come here, and here is a bond, there is a bond, and this, see, this will come here. So how it will come here? First, see, this bond which has lone pair of electrons will come at this nitrogen point. Nitrogen structure is like this. So how it will take it is an electron attracting group. It will attract these lone pair of electron towards itself. When oxygen will take a pair of electron towards itself. So it will become deficient. Okay, when it will become deficient, then it will attract the electron towards itself like this. Okay, this bond will be attracted. Here is a bond, it will be attracted like this. Okay, so this is not now this is I am explaining you this structure will, I have opened this structure here. Now in the next step what will happen? Okay, in the next step what will happen? N double bond O, not double bond O, the negative charge comes here, and it is like this, and it is like this. Now it has lone pair of electrons. Now in the next step what will happen? In the next step, again the charge relocalization will happen. This lone pair of electron will shift here. When it will shift here, then these lone pair of electrons will shift at this point. And when this lone pair of electron will shift at this point, this bond will shift at here. Okay, so a structure will be formed like this. Okay, this will form again like this, and this bond will come here like this. Negative charge will come here. It is double bond O, and this bond will be like this. Okay, now this will shift here, and this bond will shift at this oxygen atom. So what will form is bond O, O, phenoxide ion. So when nitro group is attached to the phenoxide ion, it is an electron attracting group, so it will attract the electron towards itself and allow the resonance, or will make the structure stable. Okay, now see, I explain you again what happened when phenoxide ion has nitro group, then how the reaction will take place. See, first of all, this lone pair of electron will shift here, then this bond will shift here at this carbon point, this bond. Okay, like this. Here double bond O will come, and this bond will be like this. Then it will come here, this lone pair of electron will come like this. Okay, so first what will happen? I have explained you in this structure. I have opened this structure. this bond means lone pair of electron will shift to the oxygen, being more electronegative, will take the lone pair of electron towards itself. It will become deficient and it will take the lone pair of electrons. Because it has to shift here, so it will take the lone pair of electrons. When it will take the lone pair of electrons, then what will happen? Then again the cycle will continue. Now it will give back its electron here in this structure, because charge is spreading throughout the ring, and when it will give the charge or lone pair of electrons here, then these lone pair of electron will shift here at this point. Okay, and when this lone pair of electron will shift at this bond, it has to complete its valency, will shift at this carbon point. Okay, now a structure will form like this. Now this bond will shift here, because it is here now. It is here now. It will shift here. When it will shift here, then this bond will shift at the oxygen. Now it has shifted on the oxygen. Okay. Now it is spreading the negative charge throughout the ring. It is a stable one. Okay. Now this is electron attracting group, which increases the acidity of phenol. Now we will talk about the electron repelling groups. Electron repelling groups are those groups which do not attract the electrons. In fact, they repel the electrons. Electron repelling groups. Like for example, NH2 methyl group. Okay. Now OCH3. These are electron repelling groups. These repel the electrons. Okay. Now if this group get attached, like here, to the phenoxide ion, like this, when this is the phenoxide ion, when proton has dissociated. Okay. Now if it happens like this group as attached, then what happens? It will repel the electron. When it will repel the electron, then what will happen? It will not spread the charge. In fact, the electrons will intensify on the phenoxy-oxygen. Okay. It will not take the electrons towards itself. It will not allow the electrons to spread throughout the ring. So the charge or the electrons will intensify at the phenoxy-oxygen, and therefore it will attract the proton, which was dissociated earlier. So it will decrease the acidity of phenol. So electron attracting group attracts the acidity, whereas electron repelling group decreases the acidity of phenol. Okay. So for now it's over. We will meet in next video. Till then, goodbye. Have a great day.